Okay, welcome to lecture 4.8 here. All I'm going to do is give you a kind of preview of what we're doing in session 5. In session 5, we're going to focus on the Krehbiel-Rivers paper. Okay, in the Krehbiel-Rivers paper, Krehbiel and Rivers analyze, I think it's two roll call votes on the minimum wage. And I think both of these were amendments. But the key was there was a yay vote that meant a certain minimum wage, a nay vote meant another minimum wage, and you could see, assuming revealed preferences, how they vote depends on which of the two numbers they prefer as their own minimum wage. Okay. And by these two votes, Krehbiel and Rivers are going to estimate ideal points. They're going to estimate each senator's ideal minimum wage, an estimate. Okay, so here's what happens. There's some notation. XI equals senator I's ideal point for the minimum wage. And this was, I think, it was early 80s, something like that. So there's inflation. I can't remember. I think like minimum wage was like $3 an hour or something. So XI is going to be a number, something like 325 or 450 or 215. Okay. Senator I's ideal, if he or she can implement the minimum wage he or she wanted, that's it, XI. Okay. The issue space, plus minimum wage, was just a number. Okay. Theta J equals alternative J. And so what we're going to assume is that in these roll call votes, there's going to be a yay alternative and a nay alternative. Each one indicates a number for the minimum wage. Now, it turns out Krehbiel was my advisor, and he told me, he said, once you do it, these things are, what he said, we're going to test like the median voter theorem. And the median voter theorem assumes that the issue space is one-dimensional. And Keith Krehbiel told me, he said, everyone, I thought there must be loads of bills out there where everything is one-dimensional. It's going to be easy to estimate ideal points. And so I started looking at it, and God, almost none is it ever the case. Like you look at some spending bill, it's never spending on just one program. It'll be spending over 20 different programs, and so it's a 20-dimensional bill. He said, so, most of these appropriations bills wouldn't work. I said, okay, minimum wage. He said he looked at that, and the problem is then there would be these amendments to have like two separate minimum wages, a regular minimum wage and a teenage minimum wage. And there's another bill that says, well, let's have a transition period to account for inflation, that the first year, if it goes up, the minimum wage goes up 30%, let's have it. It only goes up 10% the first year, 20% the second year, and then it's 30% from here on out. So you have these 2 years of transitional minimum wages. And all of a sudden, the bill is a three-dimensional object, the two transition wages plus the steady state wages. And Keith said, it was really difficult. So what we did is kind of had to wave our hands a little bit and ignore the transitional wages, look only at the steady states, ignore the amendments on cases where they wanted to have a teenage minimum wage. So anyway, in this case, there's going to be three alternatives. It's basically going to be a bill, Amendment 1, Amendment 2. Each one is going to represent a different minimum wage, and that will be called Theta J. So there's going to be a Theta 1, Theta 2, and Theta 3. Okay. Okay, next. Krehbiel and Rivers assume that Senator I's utility for alternative J, and by the way, this could trip up economists. Economists, we always think about the utility as something that we get. Okay, it's over the objects that we get. So we would assume that the utility of theta j, it's the utility of the policy that is put in place, the policy that becomes the law of the land. That's not what Krehbiel and Rivers assume. Instead, they assume you get utility out of voting for something. The utility is not for what is the resulting policy. Okay, so if you're familiar with, oh God, what's I can't think of the Yale political science is much of what members of Congress do. David Mayhew, as much of what members of Congress do is position taking. They take positions, and he says part of voting is doing that, saying, I'm voting yay or nay on this issue. I'm taking a position that I prefer this one to that one. Okay, and Krehbiel and Rivers are assuming that these guys don't really care about policy. They're pure position takers. That's all they're doing, is they're getting utility out of what they vote for. And the reason you have to do this is because if you only cared about policy and didn't care about the position you take or what you voted for, if you're not pivotal, if the final vote does not involve a one vote margin, if it's 70-30, so that means none of the legislators are pivotal. So it means they could change their vote and it doesn't affect the final policy. So to get around that, Krehbiel and Rivers say, well, we're going to assume that they're pure position takers. All they care about is what they vote for. So keep that in mind. So Senator I's utility for voting for theta j, alternative theta j, equals, little phi of I of parentheses absolute value theta j minus xi. Okay, so remember these are scalars, so it's just the alternative minus your ideal point. Take the absolute value of that, where phi is any strictly decreasing function. Okay. This looks more complicated than it really is. If Krehbiel and Rivers wanted to, they could have just taken that out and assumed ui theta j just equals negative absolute value theta j minus xi. Okay. They wanted to make it simple. That's what they would have assumed. They wanted to say, look, we don't need to make that particular assumption. We can keep everything very, very general. Assume that utility is could have a lot of different shapes. We don't have to have. By the way, when we describe that, that's tent utility. So what happens is if the utility for person I and the utilities over different policies theta j, what this looks like is this is 0. The utility is maximized when theta j equals I, and if it goes less than xi or more, utility is decreasing. Okay. So that's what that looks like. Instead, they could have had, they said, that phi, in this case that I've done, phi is just the negative z. Phi is just the negative of whatever is in the argument. We could have had, so this case, phi of z just equals negative z. It's negative what's in that absolute value. So okay, that's example 1. Example 2, it could be, let's have phi I equals, let's make it phi I z equals negative z squared. Okay. if that's the case, then u sub I of theta j just equals negative of theta j minus xi absolute value squared. That just equals negative negative theta j minus xi squared, because take the absolute, if it's the absolute value of something, that's got to be positive, but if you take the square of it, take it squared, it's going to remain positive. What this means is the utility function looks like this. So if that's 0, it's utility I. This is theta j. Ideal point is xi. Utility is going to be quadratic. It's going to, if we plug in different values of theta j, utility is going to look like this kind of mountain shape. Okay. Example 3, if phi I of z, instead it said it can be any strictly decreasing function. So here's another one, negative square root of z. Okay, I won't go through the math, but if that's the case, if that's 0, it's theta j, there's xi, the utility function is going to look like that. Okay, actually it can be less than 0. Okay, but it's going to have this concave area on one side, concave on the other, or excuse me, convex. Okay, but okay. So when Krehbiel and Rivers say that they assume phi it can be any value, I gave you 3 examples. Okay, now I'm going to show you that what happens is, because they take phi of the absolute value of the difference theta j and xi, the function becomes much simpler. Okay. Okay. Now the key is each of those examples. Okay, and as long as phi is strictly negative and it's phi of, remember it's ui equals phi I of xi minus theta j, because you're taking the absolute value of the difference. Okay, you can show that what that means is that the utility function is going to be symmetric. And I showed you 3 examples. It's going to be symmetric about that ideal point. On either side of xi, when it's a function of theta, the utility function has to look symmetric. Okay. Because of that, okay, because ui is symmetric, the following must be true. Okay. Let theta 1 and theta 2 be 2 alternatives that they're voting on. Okay. Center I is indifferent if and only if xi equals theta 1 plus theta 2 divided by 2. Okay, the idea is that if that's xi, that utility function is symmetric. If he's indifferent between theta 1 and theta 2, the heights must be the same. Okay, that's what indifference would require. But if that utility function is symmetric, it means they have to be the same distance away from xi. And if there's the same distance from xi, it means that the midpoint of the two of them has to equal xi. Okay. So xi has to equal theta 1 plus theta 2. Okay. Next. Okay. Next, assume theta 1 is less than theta 2. Okay. Then I prefers theta 1 if and only if xi is less than the midpoint of those two. Theta 1 plus theta 2 divided by 2. The idea is if it's theta 1, theta 2, the person who's indifferent has got to be the one here. And then, actually, I'm not going to prove it, but if the xi, so that is the xi that's indifferent. The utility functions have a peak at the ideal point. They're strictly sloped down on either side. Means if the xi is here, person i's got to prefer theta 1 to theta 2. Same thing if xi is here, he's got to prefer theta 1 to theta 2. Okay. Given that, okay, so Krehbiel and Rivers could have just made a simple assumption. So we assume they vote for theta 1 over theta 2 if and only if their ideal point is less than the midpoint. Could have made that assumption, but they said here's a set of maybe more primitive assumptions. You make that assumption about the phi and so forth. Those assumptions give you this, okay? But this is the key thing they need. They need to make some assumptions to get this implication. They could have just assumed that. Would have been a little simpler, but they didn't. But once you see that, those assumptions they make give you that, okay? The final thing, here's what they're going to do. One thing that's a little bit unorthodox, okay? Before, we always had our dependent variable be yi, and we had yi star equals the latent variable. Okay, now xi with no star on it equals the latent variable. Okay, that equals i's ideal point. We don't see that. We, the researcher, will not see person i's ideal point, okay? But we can estimate it, okay? We assume, Krehbiel and Rivers assume xi equals zi prime gamma, okay? So this is like a regression, okay? Zi prime is a vector of independent variables. Gamma is a vector of parameters. And then we're going to have an error term, epsilon I, that describes the ideal point. That's the part we, the researcher, don't see. And by the way, you could call this as a special case of what's sometimes called the McFadden random utility model. So this, I guess it's not utility, but I guess epsilon I is part of the ideal point. But like the McFadden paper, Senator I knows his own epsilon I. We, the researcher, do not. And what we're going to do, the zi is going to be some independent variables. And it's going to include things like the party of Senator I, the percent of union members in I's district, the average manufacturing wage in I's district, the percent unemployment in I's district, and then percent of, I percent of black voters in the state. And the idea is that black voters are more liberal and they're willing to vote for a higher minimum wage. There's a lot of things that are kind of proxies for being liberal. Maybe especially that manufacturing, unemployment and manufacturing wage. Supposedly that's specific labor-related variables. But in every case, there's a set of independent variables that's going to be the ZIs. We're going to use those ZIs to try to get an estimate of XI. Now, what we're going to do is we're going to have two different votes, and they're going to have like a theta 1, theta 2, and a theta 3. And so they had one vote where it's theta 2 versus theta 3, and then another vote where it's theta 1 versus theta 3. And each one of those makes a cut point. That's the midpoint between the two alternatives that separate the legislators. So if you vote for theta 3 on that first vote, that means your XI's got to be bigger than that. So remember in the probit, we said if you vote yay, then your YI star has got to be greater than 0. Here, we're going to say if you vote yay on this one, your XI has got to be bigger than that. If you vote nay on both of them, your XI has got to be over here. And if you vote yay on one, nay on the other, your XI has to be in there. So it's going to be like probit or logit, okay, where probit or logit, we knew which side of a particular value, or actually the 0 value. If the latent variable for person I is higher or lower than that 0 point. Here, we're going to have a little bit more information. We're going to know not just above or below a 0 point, we're going to know which of these 3 different areas the legislator is in, okay? And we're going to use those things to create a dependent variable. From that, we're going to estimate the gamma. And then from that, we're going to do things like we can give our estimate of the median XI, things like that. Okay, so that is where we're going. Okay, encourage you to read that paper by Krehbiel and Rivers. And then we'll talk about that in session 5. I'll see you then.